programming in APL requires a certain kind of abstract geometric intuition. And some people don't like that. So David Shaw is a super, super smart guy. But he said, it doesn't appeal to me. I'm more of a algebra, one potato, two potato, looping kind of guy.
Welcome to another episode of ArrayCast. My name is Connor. I'll be your host. And today we have a super exciting guest that I can't wait to start interviewing and talking to. But before we do that, we're going to do brief introductions. I'll throw it first to Stephen, and then we'll go to Bob, who also has an announcement, and then we will introduce our guest.
I'm Stephen Taylor. I code in APL and Q, and these days I'm the KX librarian.
And I'm Bob Terrio. I'm a J enthusiast. I'm working right now with the JWiki group, and we're trying to revamp the JWiki, and it's been a lot of fun, and it's exciting. And if anybody's interested in starting with something from the ground up, that's a good place to start. And also on the J front, for announcements, we're also working on our beta, our new beta. Henry Rich is working on that, and it involves the threads and the whole concept of threading J. And if you're interested in that kind of thing, it's really a good idea to get on the J forums. We'll include links for that and start talking to people if you have experience with that, because they're starting to figure out, with all the different paradigms you can use for instituting threading and blocking and all these different devices, they're working out how that might work as a primitive for J. So kind of interesting stuff going on, and that's it in the J world.
Awesome. So yeah, as always, the links will be in the show notes that you can access. And as mentioned before, my name's Connor, and I'm not a APL-JK BQN developer. I code in C++ professionally, but I'm a huge fan, as listeners of this podcast will know, of both array languages and combinators. And that brings us to introducing our guest today. So if you've been listening regularly, you will know that 2 weeks ago, we interviewed Stephen Apter. And if you couldn't tell, I absolutely loved that conversation. Basically, after recording that, I went and watched, I think, 5 or 6 different talks. And one of those talks was, let me get the exact title of it. It will be in the show notes. It was, the name of the YouTube video is Joel Kaplan, an idiosyncratic look at the history of array processing languages, which I believe was given roughly 5 or 6 years ago. So that'll be back around 2016. And I went and watched this talk because Stephen Apter recommended us bringing on Joel, and he linked us this talk, to which I immediately went and watched. And this talk was absolutely fantastic. It's sort of a perspective on the history of array languages from Joel's point of view. So if you don't know, Joel Kaplan is today as our guest. And the brief biography of him, he worked, I believe, for over 10 years at Morgan Stanley, for which he is known for many things, but one of them being the hiring of Arthur Whitney. And hopefully we'll get to hear the story of interviewing him and any fun stories there. He then went on to work at UBS, so also in the finance industry, and then ended his career as the president of 1010 Data, which is the company that Stephen was working for as well. So I'll stop there. We'll throw it to you, Joel. You feel free to take us back to whatever point in your career or life that you want and tell us the story of how you ended up where you are today, having had a very long and storied career in the with array languages.
Well, not too long ago, actually, after, since I've been involved with array languages for a long time, somebody pointed out that my name, Joel Kaplan, has all the, major vector languages: J, APL, A, K, so. But it's interesting because my life was, I collided with APL way back, and it had a profound impact on my career. I had transferred to the University of Miami from the University of Florida. In the University of Florida, I had taken one programming course. I was in mechanical engineering, and it was a Fortran course on a VM machine, a CP67. That's all that I had as an experience, and I really liked programming. At the University of Miami, I had a colleague, a fraternity brother, a friend of mine, who came up with this idea called Doggy Match, a computerized mating service for dogs. Now, you have to understand, this is happening in 1968. And we were using a PL1 account that we had as students, And then we ran into this very, very colorful guy, a guy named Brooks White. And I really got to tell you about this because this guy was really cool. So Brooks White eventually wrote a processor so that APL could talk to other systems. And, this idea of predicting elections, the first election ever predicted was predicted in CBS using APL. I don't know if you know that. And it was Brooks White who did that. He was also kind of like a radical, kind of he didn't look crazy. He was, wear button-down shirts and everything like that, but he was really quite a weird guy. And he started with another guy, an APL time-sharing service on an IBM 360 Model 30. And they were looking for customers. So me and Bruce Cousins, my colleague, said to him, look, we're starting this business called Doggy Match, and you got a time-sharing service here. So we can go to dog shows, and if you want, you can participate in any profits that we make because we don't have the money to pay you for the time-sharing service. And so they went along with it. And so this whole thing started. And Doggy Match, it was a time it was quite popular. My partner ended up in What's My Line. And it's amazing how quickly they guessed it, what he was doing. And, and we were interviewed all over the world because it's kind of funny. I could read it to you, but I'm not going to waste time. But, there's this article of a guy in Miami newspaper who interviewed us for the newspaper. All right. So that's how I got involved with APL. But the problem, the good thing was I had a DocuTel acoustic coupler. It was a huge thing. It was like it looked like today when people go in and they carry baggages, had little wheels and things like that. So there's this huge machine that had an acoustic coupler, and you can, dial in, and that's how you did the time sharing. And I had APL to do programming. I had a 30K workspace, and I could do all my assignments and things like that. At that point, I never looked back. I had lost interest in Fortran and all that other kind of stuff. So that's how I connected with APL, and it helped me through all my career. Then I ended up at IBM, and I became a systems engineer. And I don't know if you know, look, there's just so much to talk about it, and I just want to make this a long.
Feel free to take. There's sometimes these stories I just I'm this, like I said on the last interview, that this is like better than a Marvel movie. And I just saw the new Marvel movie. It was great, but like listening to these stories about how you stumbled onto APL because you were building a doggy mating business, and that the person that you reached out to for computer storage just happened to be using APL. Like that's like no one these days has stories like that.
Yeah,
everyone knows about Python from an early age. There's no like, oh, I wanted to start a business and this was the way to do it.
Let's see. So let's talk a little bit about IBM, because a lot of people don't realize how important APL was to IBM. Today, you go to IBM, you barely even hear of it. Mm-hmm. In the late 60s and through the 70s, IBM had hundreds of mainframes dedicated to running APL programming. And the reason was anything that had to do with financial planning or figuring out how you're going to lay out a run of chips or whatever it was, that required analytics and things like that. And, APL, actually, let me back off. There's a lot of things that people think are really, really new, hot stuff, and it's really old crap. Think about it. Time sharing is like the internet. In APL, you even had a thing called open paren, close paren, MSG. You could talk to people. You could send them messages. You didn't need to have operators and all kinds of people, screwing around with your life. You could just do the work yourself, and you had access to the computer, and it's almost like a personal computer. So by definition, smart people at IBM, people really that wanted to get their jobs done, where computing was only a means to an end, started using APL because all the other stuff was so bureaucratic. There was so many steps that you had to go through and so on that they didn't want to do it. So you had unbelievable, IBM's APL conferences, internal ones, were bigger than the APL conferences outside of IBM, which obviously were highly attended by IBM professionals. And there were products that were developed. For example, APL-DI. Has anybody heard about APL-DI? It's called APL Data Interface. It's really basically what 1010 Data is doing. You had a COBOL program that loaded data and sort of inverted it, tipped it on its side. You had records and it tipped it on its side. And then you could do analysis. You can do selects, you can do sorts, you can do tabulations, et cetera, et cetera. So people use this everywhere to do analysis. And so people lose also in order for IBM what the systems engineers did is they had to configure hardware that was quite complicated, very expensive hardware. Mostly at that time was being rented out. And you had to configure them. And all the programs, all the configurators, that the systems engineers at the branch offices used were all written in APL because they could be updated quickly and they were easy to work with. So like I'm saying, you can't imagine the importance of APL in those years at IBM.
How long did that last? So I'm guessing this was late 60s to into the 70s,
Yes, maybe to the early 80s.
So, Joel, what caused them to drift away from it? That seems to me that would be pretty central to what they're doing. You've got all these engineers working with these sort of fundamental level applications in APL. Why do you think it was that it suddenly drifted away? Was IBM concerned about the engineers having too much independence, or what do you think it was?
I don't think APL appeals to the programmers. I mean, to some it does. I mean, you have Brooks, who used APL to define, the 360 architecture and things like that. But by and large, programmers aren't in the mode of doing applications or understanding things. They're into their own stuff, so they don't want to invent other things. There's a lot of people who don't like it. It's also a cognitive thing. You know who David Shaw is? Have you ever heard D.E. Shaw?
Yeah, it's the hedge fund guy.
Yeah. Well, David Shaw worked in my group. And I remember that I came to him. And by the way, he's a big guy in he did many advances in how to do parallel processing. And also he had a company, he was at Columbia, he was a person, but he also had a company that built compilers to try to, produce code that ran in parallel. And I remember I was talking to him. I said to him, what do you think APL? Because he was in our shop there. We're doing this is the APT, the Analytic Proprietary Trading Group, which we traded like 2% of the New York Stock Exchange in the 80s. Was
this at Morgan Stanley?
Yeah, Morgan Stanley. So he came into our group, and he said to me, I'm not a geometric kind of guy. I don't view the world geometrically. And of course, arrays and things like that are all very, very, appeal to geometry. I mean, if you look at a lot of the transformations, a lot of the operators in APL, they're really transformational. In other words, you rotate. You can imagine it in your mind. You can actually imagine implementing all the APL operators, the primitives, and you can actually make a physical implementation, right? I mean, you can imagine, indexing or rotating or transposing or catenating. All those kinds of things are very, structural, if you will. So it's very geometric. And programming in APL requires a certain kind of abstract, geometric intuition. And some people don't like that. So David Shaw is a super, super smart guy. But he said to me, it doesn't appeal to me. I'm more of a, like a algebra, one potato, two potato, looping kind of guy. And that's just the way it is. Let me tell you, he's a very bright guy. He certainly made a lot of money after he left, Morgan Stanley. So I think it's a lot of it is also cognitive.
So first of all, I think that's an amazing quote. The one potato, two potato, four looping guy is fantastic. Two, as soon as I said the hedge fund guy, I realized I hadn't done service because I've read a bunch of books, so I know who D.E. Shaw is. But for those that don't, a lot of money is like, I think I just Googled his net worth. It's like $8 billion. So D.E. Shaw is like one of the most successful hedge funds of all time. Famously, Bezos worked there at one point and decided to quit when he was 30 and then went and made a small company to sell books online. And we all know how that went. So yes. And so David Shaw worked in your group at one point, basically, and then went on to do D.E. Shaw later. Like,
yes.
Wow.
Also, by the way, Bezos was, when I was a principal, I eventually became managing director at Morgan Stanley. But Bezos was also at the same time as I was in Morgan Stanley.
Bezos worked at Morgan Stanley as well?
Yeah.
Wow, I had no idea. And so then, how did they work together, or how did Bezos end up at D.E. Shaw?
No, I don't know. I don't think so.
It's just a coincidence that they were both two different places. Wow. Okay, so that's crazy. So go ahead, Stephen.
Jill, this may be the same question, or at any rate the same answer as the question Bob asked. For all its importance at IBM of providing personal computing before personal computers existed, as far as I know, APL was never part of the solutions that IBM salesmen took to propose to their customers. The solutions were, of course, mainframes, but there was software with them, and the solutions were PL1 and their databases in them. But APL never seemed to be part of that. Was that just the same cognitive thing you were thinking of, or is it something else there? Did IBM think they knew something about APL? We didn't.
Well, they tried to sell it, and they were fairly successful at it. I mean, along with other companies like DEC. It was basically APL. Again, it's a time-sharing thing. It was just like almost ahead of its time, right? It requires basically like the big invention. I think that APL was one, if not the first, one of the first languages that was implemented as an interpreter, and I think it's a tremendous value. Space over 6, you know what I'm talking about? Space over 3, you know what I'm talking about? You key in something. Imagine that you're on a terminal. In those days, a lot of it was just with paper. You say 1 + 1, and then the computer shifts over to the right. It says 2. You know what I'm saying? This idea, this interactive idea, was very powerful. It's kind of like what the web is really like on some level. There's an interactivity kind of thing. So most of the systems that IBM was selling were like big operating systems kind of stuff. And applications for accounting and bookkeeping and all that kind of stuff. But they did try to do it. And I'll also point out the first personal computer was the IBM 5100, and that one had APL on it. And you had a switch. You can go to basic or APL, and it had just a tape. It didn't have even disk. I loved that machine. I got one. Somebody gave it to me at the branch office, the banking branch office, because they wanted me to work on my own time to build an application that would keep track of all the, witnesses and things like that at the IBM antitrust thing. And that's how I got involved with the 5100. So they did try to sell it. This may be a good point. Bill Gates, right? This is going to blow your mind if you don't know this. Bill Gates goes off and basically he starts by building a basic interpreter. But before he built the basic interpreter, he actually built an APL interpreter. And because he thought it was great. He loved APL. I mean, so I got to give Gates credit for that. But what happened was it didn't get any traction. And being a good businessman, he dropped that. Then IBM came along and they gave him the opportunity to build an operating system and so forth. I had a conversation with Bill Gates. He came to visit Morgan Stanley, and this is how I found out. He was introducing why did he come to Morgan Stanley? Because Morgan Stanley brought them public. Okay, and so he's always looking for big customers to try to see where he can sell his stuff and, kind of understand places that use technology. So he came to, sort of like on a visit to Morgan Stanley. And it was during the festival of Sukkot, so I wasn't able to go to a meeting where he spent a lot of time with the technology guys. But then he had one more meeting, and I showed up to that one, and there weren't too many guys there. And I was really giving him a hard time. I said, why should I get stuck with a system that's controlled by you, and it requires your software isn't open or anything like that? I mean, I'd rather. This is like, by the way, in the early 80s. And I said to him, why are you, why should I do that? Why should I commit myself to you? And he gave me some great answers like, his stuff is always hardware compatible, blah, blah, blah. Not anymore, but it used to be then. And so we got to talking about what we do. Because he said, so how do you do things? So I said, well, we wrote our own APL here, called A. And, we use it for trading and for analysis because it gives you a lot of capability. He says, yeah, but wait a minute. He says, APL, but that's too slow. And I said, not our interpreter. This is the one that Arthur, wrote for me, for my group. So he all of a sudden, he really got, got really attentive, And he said, but so you're telling me that you use APL in production form and everything like that? I said, yeah. And so he pointed out to one of his guys, some technical guy that was with him. I mean, I think it's a combination, bodyguard, technical guy, because he had a little thing in the ear. And he says, you have to follow up. I want to know what these guys are doing. I mean, he never did, and I really didn't care because I was not in the business of trying to sell anything. I mean, we were just trading money for Morgan Stanley at that time. But I mean, but that's when, then I started looking into it, and Bill Gates actually tried to build an APL interpreter. Imagine if that had, gotten traction.
How did you find out that he had actually written one? Because I've heard rumors of these stories, but I'd never heard that he'd actually written an interpreter.
Yeah, I looked it up on the web, and there's some letter, I wish I had it, where he's talking about, in pretty glowing terms about it. So at any rate, I mean, look, it's got to be a small thing in his life, right. But nevertheless, it's like you don't expect it. By the way, another thing that had a big impact on APL is the fact that in the early days, the character set, if you wanted to get the APL character set, you had to have hardware. You had to do something that was hardware related to in your system. And then, it was a real big pain in the butt to get the APL character set. Yeah, I know, because I had to do it too. But then, of course, very quickly thereafter, everything became software. So, you think, well, what's the problem? But it's, it was already slowing you down,
So when I first started falling down the APL rabbit hole a couple of years ago, I had come across this story after talking to Bob Bernanke that Bill Gates had come by IP Sharp and Associates back in the early 80s as well. And he was basically doing this tour of companies around North America trying to, get ideas for the PC that he was going to build. And then I'd heard that story, and then I also stumbled across a photo of an IBM 5100 and zoomed in and saw like the APL basic toggle switch. And ever since, I've always thought that there's like a parallel universe where instead of putting basic on the personal computer, some APL variant was put on, and instead of everything looking like basic, everything looked a lot more like APL or something. I'm not sure if you have thoughts on is there actual, because you mentioned earlier too that the geometric or shape thinking that sort of is required for APL, a lot of people don't like that, or that's not the way their brain works. So do you think that there is actually a parallel universe, or there's just too much of a barrier to entry in terms of the type of thinking that it requires to be successful with APL?
Let me just talk about myself. For example, I basically use two languages when I program. I use C and I use APL. I mean, okay, I don't use APL anymore for many reasons, but primarily because that, we committed to that kind of technology, and intent and data and so on. But basically, APL for me is the high level. That's where you could use a lot of leverage. But in my experience, and the kind of systems that we built require that they be high performance, high speed kind of stuff. So performance becomes critical. I know many people have taken the approach of trying to build the APL compilers and things like that. But for me, if you have a good interface between C, let's say, or any language actually, then whenever I get into a situation where either I'm not smart enough or it just is a one potato, two potato problem, then for the very small amount of code that's required, which may actually dominate from a CPU cycles point of view, then I just dive in and write a small piece of code in C, and I interact, and I just call it as a function from. So, I mean, I'm both capable of doing, thinking in both ways. Some people can do one, some people can do both, and some people can do none. But, I think you have all different kinds. For example, Arthur Whitney, clearly, I mean, he spends most of his time implementing stuff in C. So he's probably, one of the greatest programmers that, if not the best programmer that I've ever met. And yet he's a great, array guy. I mean, he can, I got to tell you about, I interviewed how we hired him. So he comes from, from IP Sharp. We interview him. I'm interviewing the guy, and we have a problem. We're looking at, we have a problem of trying to determine nearest neighbors. You know what that is? It's sort of like an abstract measure to know if something is like something else. And we're struggling to try to do this in APL, in A at that time. No, that was APL, because he hadn't even been hired. He only did that afterwards. And we posed the problem, and I've been struggling. Some pretty decent APL programmers have been struggling with this thing. I kid you not, his eyes went kind of like to the left, like looking out. And in like 12 seconds, he went up to the board and he wrote 6 APL characters. And it was a solution to our nearest neighbor's problem. So I looked at the guy and says, we're going to hire this guy. So you didn't
send him for 5 more interviews?
No. I mean, he talked to a bunch of other guys, but I mean, everyone had the same impression. So at any rate, I think you have different minds. But again, there are people that have a difficult time. I have my biggest problem is in recursion. I know how to do it, but it doesn't come naturally in me. I mean, programs that are purely recursive, it's hard for me. I mean, so you have difficulties. So I don't know. I mean,
Stephen?
Joe, I got a question I've been chewing on for some time. I'm wondering if you can help get me some insight into it. In 1978, when I was working for IP Sharp Associates, I was over in Toronto, and I arranged to go cycling with Barnicki because I knew he rode a bicycle. I was a young sprogger in my mid-20s, and so this was I thought this was a bit of a cheek me asking Bob to take me cycling in Toronto, but he agreed to do it. However, on the day, something came up, and he sent me out with some other young guy who, at the time, I thought I was working with the Zoo IP Sharp's a systems programming team. Well, that young guy took me cycling through Toronto in the most terrifying fashion. We go the wrong way up, one-way street. So we went up with his girlfriend. The two of us were like struggling to keep up with him. That was, of course, Arthur. Back a couple of years later, a few years later, in '83, Chris Sanderson, who was running IP Sharp Associates in Australia, wanted to port the Sharp APL interpreter onto a Hewlett-Packard mini computer. And for some reason, I told him he should have to talk to Arthur. And for the life of me, I can't work out what it was I thought I knew about this young man that would make him a good candidate for that. You decided to interview him a year or two later in Morgan Stanley. Why did you interview him? What did you know?
Well, he came with an incredible reputation. Also, I don't know if you know, he was like the bad child at the APL conferences, the APL developers conferences. He's really a funny guy. Let me give you an example. He worked on a generalization of the axis operator, which is a big deal in APL. And he figured out how you can define like 20 different primitives as in terms of the axis operator, right? So you think that he'd be, invested in whatever. he'll drop an idea if it doesn't work. I mean, it's interesting how he's not attached necessarily to any particular thing. Because later on, when he went and he's doing K, he dropped the idea altogether. I mean, I've seen him go back, and he has tremendous fondness for APL. Things that he dropped and ignored or changed or, they didn't do or whatever. Then he comes back and he says, oh, that's pretty good. And he'll adopt it. I mean, he has a bizarre mind. I was asking, well, what are the most important, what was the most important guidance in the development of K? And you know what he told me? Now, can you try to guess what it was that he said?
Starting from scratch each time? I have no idea.
Well, he always starts from scratch. He throws all the code. He starts from scratch anyways. But not always does he throw away the idea. No. His major driving force for the design of the K interpreter is the QWERTY keyboard.
Really?
Yes. He in other words, you might call it an arbitrary constraint. I mean, this is opposite of what Apter was telling you how, and I like it too, all these characters and everything like that. And Iverson loves that because he's a mathematician kind of guy. But he said that he wanted to make sure that whatever his language was fit on a regular keyboard. And that particular set of constraints led him to figure out what primitives he should have and so on. I mean, it's mind-boggling, but he was really serious. He's told me some things that are like totally mind-boggling. I remember when we were doing A was a language that we developed in Morgan Stanley, which is an extension. It was basically APL, but an extension of it that actually had one-level dictionaries. But at any rate, I remember one of the guys was saying, "Well, how are we going to debug this interpreter, right?" Because I mean, and by the way, Arthur's code is the cleanest code that I've ever seen. I'm not saying it doesn't have bugs, but I am saying it's seriously, seriously good code, even when it first goes out. He said he looked at this guy the guy's name is David Weiss. He says, "I'll tell you what, I'll put in any feature you want me to put in this thing, but for every feature, the new feature you want me to put in, you got to tell me which feature goes out." It's like. And then another time, the guy said, "Well, how are we going to debug it?" He said, "Oh, if I have to debug this," and I never understood that until much later. "Oh, you really want you want this thing to be bug free? Well, then I'll have to spend a couple of months reading the code." Can you imagine what in other words, think about it. Usually, you run something and you test it, and and if it breaks, you know where to go, whatever. But for Arthur, the way his mind worked is, if you really want to debug the thing, he had to go and read the code very, very carefully. Not execute the code, read the code. It seemed to me like an absurd idea when I heard it. It was only maybe 20 years later, after I was doing some kind of, for example, I think I was doing this parallel processing thing with many tasks, that's not usually what I used to do, but I got into that. And I had a really hard problem, and it was really impossible to test because there's so many conditions that, that come in, and there's all this time shit and everything like that. And I found myself, number one, thinking that you better design it right from scratch. And really, it's a matter of reading the code and understanding that problems can't really arise. Because if your code is loose, you'll never even be able to debug it. And it's only 20 years later that I understood it. And it seemed absurd when he first said it to me. But I'm saying he's an interesting kind of guy. Also, other thing about the design of K, Arthur's design goal was that the slowest primitive to the fastest primitive have to live within one order of magnitude in speed. Right? So in other words, you can't have operations that are powerful but impractical from a CPU point of view. And I'll tell you another example where this showed up, immensely. There was a company called Analogic that was building what today is called a GPU. This is happening in the 80s, right? Maybe the 80s. And so it's got parallel stuff in it and whatever. And the guy the owner of the company got interested in APL because APL, has a lot of ideas that, the operators work sort of like, all a bunch of things as opposed to just individual, one potato, two potato stuff. And they built an APL interpreter. You can look it up, Analogic, okay? It was astoundingly fast on the operations that parallelized well. But it was an impractical machine because every once in a while, you had to resort to an operator that didn't parallelize. And what would happen is the thing would it would take 500 times or 1,000 times longer to do it. So it really wasn't even practical. So for Arthur, and he uses, techniques to make sure that the language is fast all along so you can really be expressive. Otherwise, it's not practical. So, I've been going on for a long time. Maybe you have.
No. So it's amazing that this came up organically because when I was watching your history of array languages talk, the one from 2016, you mentioned at one point this test analogic system, and I tried to Google for it and couldn't really find it. And I even went and asked because I work at NVIDIA, where we're one of the biggest GPU manufacturers in the world, and asked a couple folks that have been around for a long time had they heard of this test analogic interpreter, and none of them had heard of it, but they said that if it was earlier than the 90s, that GPU programming was in its infancy, so it wouldn't be surprising if an attempt at something like this, where you were accelerating the whole language, really didn't go far because of exactly what you're saying. You're going to get some little micro pieces of it that are blazingly fast, but as a system, it's not going to work well. And I'm curious if there's been any other company that has tried to do that, since the advent of CUDA programming or sort of modern GPUs, but I haven't been able to track down any kind of startup or company that is attempting that, because it seems like now in the 21st century, that would be something that could be successful if done correctly. Bob?
Yeah, well, actually, going back to what you were talking about, Joel, with the understanding of the programming and having to read it to say I could debug it, that actually reminds me of something that Aaron Shu had said, or I've heard Aaron Shu talk about in his code defense compiler, is that he finds now that he understands it so tightly, he can look at it and make very quick changes to it because he's almost internalized the process so tightly that he can see exactly what he needs to do, and he doesn't have all these side effects rippling through. It's a level of understanding of a program that I don't think most people who write or program actually get to, because they do get into that loop of, I'll try this, oh, it didn't work. I'll try this, it didn't work. As long as you're working in that area, you're never really going to understand what you're doing. It's like writing and rewriting literature, I think. You could get to a very good piece of literature, but if you if you're one of those people that really understands what's going on, you're like Shakespeare. You can put words together in such a way that it just really works, and it wouldn't be put together any other way. Do you think that's sort of what's going on with these, I want to say times 10, but it's probably times 1,000 or 100,000 programmers, where they're actually working at a different level of understanding of what the programs are doing?
Yeah, for example, the smartest guy, like I said, the best programmer that I know, there's another guy, by the way, you may want to interview him. His name is Adam Jacobs. He works at 1010 Data. But I don't want to, but anyways, Arthur, every time he writes a new language, it gets smaller. And it does more, and it's faster. And if you look at his code, it's bizarre. He'll have the source for K, right? I don't know, it's 140K, the whole interpreter. And that one included GUI. That one had a GUI. Basically, he has A.C, B.C, C.C, D.D, and just a few things. And every one of these, scripts fits on a screen, very easily on a screen. And he writes C. He has these macros, so that he strings a lot of K, a lot of C things in a row. So it's totally dense. You understand what I'm saying? There isn't one blank anywhere. And it's A dot B, B dot, A dot C, B dot C dot C, and so on. And it's maybe 10 of those, and that's it. I can't tell you the numbers of times that I got into trouble, and he never ever wants to show anybody his code. Not because he doesn't want, he's just, it's because it scares the shit out of people. There was a guy from IP Sharp, I can't remember, he was a pretty big shot at Morgan Stanley too. And we showed him K. He's an APL programmer too. And he loved what he saw. And then he says, can I take a look at the code? And Arthur says, I don't really want to show it to him. I said, come on, let's show it to him. And the guy sees it. And when he saw this code, he says, this is unmaintainable and impossible to debug. And Arthur turned the machine off and looked at him and says, you're a pinhead. And I actually lost my job in Morgan Stanley eventually afterwards because I pissed this guy off. But at any rate, my point is that it's counterintuitive. But what he's trying to do is exactly what you're talking about. He's kind of has it all in his mind. He can, if you're going, we have code that's all over the place with pointers this way and whatever. It's hard to maintain. And this is for the smartest programmer. He can deal with complexity, right? Because he's smart, he keeps it as simple as possible. And that's a lesson. By the way, Apter's code, you've seen some of it because you looked at it in SNL. I mean, he's got a similar kind of stuff. But, it's counterintuitive. A lot of these things are just totally counterintuitive.
Arthur was at a conference I was at in 2014 in Toronto, a J conference, and he spoke at that. And one of the questions came up is, have you really reached the level that this can't get any faster and more compact? And his answer was, well, no, because the optimum is no code and infinitely fast.
Exactly.
And that was just as everybody kind of went, yeah, I guess if you're working in these areas, that is the optimum, and you will never reach the optimum until you can do that. He was quite happy with where he was in terms of what he'd come up with, but his target is not the usual target of what most people are aiming for.
That's true.
I wonder if you have thoughts, because seeing as we're talking about code density and Arthur's style is at the beginning of your talk, the one that I've mentioned a couple times now, you quote, I think Ken Iverson quoting Babbage, and the 3-word quote, which is it's a longer quote, but the 3 words that are bolded are brevity facilitates reasoning. And I've had this ongoing battle in my head of does the tersity, the terseness of the symbols and the fact that you can spell things so succinctly, is it important? And like even very recently, I had in my thesis that I was writing, I was talking about the expressive power that comes with being able to spell something so succinctly. And their remark was like, I don't see why this is being remarked a couple different times, that the fact that you can spell it with a few number of characters is important. And I just I wonder if you have thoughts. I feel like this is something we should be asking all our guests is does the fact that it can be spelt with so few characters, is that really like a feature, an important feature of the array languages, or is it something that potentially we over-index on?
Yes, I think it is very important. And in my story there, my talk that you saw, I cover that. I mean, it goes back. See, most languages, programming language, a lot of them are kind of very new. But since this is based on mathematical notation, it has a long history, right? Going back to, algorithmism, with, showing you how to algorithms for multiplication and so on. And, especially with Leibniz. Leibniz thought that the purpose for, having a formal logical system was to make it possible to think. I mean, I have a quote. From that paper. Let me see if I can find it. Okay, so this is Leibniz, right? He inventor of the calculus, refined binary numbering system, prolific inventor in the field of mechanical calculators. Leibniz calculus ratiocinator, which resembles symbolic logic, can be viewed as a way of making such calculations feasible. By the way, that system was in his machine that he built. That same plan was utilized hundreds of years later, still was in use. Leibniz saw symbols as important for human understanding. he attached so much importance to the development of good notations that he attributed all his discoveries in mathematics to this. His notation for the calculus is an example of his skill in this regard. And this is a quote from a Wikipedia article. So what I'm saying is you have an enormously long history. You look at today, the standard model in physics, it fits on a page, right? Now, is it easy? Not necessarily. I mean, but in a certain sense, the brevity helps. So, also understand, I mean, K or APL is a complete language, right? So if you want to write loops, you can write loops. You can express anything you want as dumbly as you like. You have a choice. But I think that there's a lot to be said for that, and it's just basically what mathematics has done. People invent mathematics. I mean, if you look at the proofs from Newton, who invented calculus, when he's selling his idea, it's all using geometry, really complicated stuff, because they didn't have the people didn't understand. So I think there's an evolution, right? So that's why I say that the APL language starts way, way, way far back. It inherits all of that, increasing generality notation that mathematics gets. So yes, it's very important.
It's really interesting because you talk about Leibniz and you talk about Newton and that whole dispute over who invented calculus. And I've never thought of it this way, but you're right. Newton had this whole way of thinking about what the calculus was and his whole way of doing it and understanding it, but found it very hard to explain it to other people. And at the same time, and I think it's pretty much acknowledged that they both invented it independently, but Leibniz did use a better notation, and Leibniz's notation was used in it's not in all areas, but in most areas.
It's the one we use today.
And as a result, Leibniz could do the same thing that this other guy, 100 miles or hundreds of miles away on the other side of the English Channel, but he was doing it with notation, and as a result, he got almost equal credit for inventing it, I think, actually, depending on what country you're in. Because I think in some countries, Leibniz is acknowledged as the inventor, and in a lot of countries, Newton is the inventor of the calculus. But the notation is really, really a powerful thing when it comes to these complicated ideas. The simpler you can make it, and I think notation helps that, the simpler you can make it to understand, the more likely it is to be able to be adopted.
Yeah, I definitely believe that. Now, some of these concepts are hard. So when you look at a line of APL or K code, some of them are very deep. But I mean, the problem that you're trying to solve is pretty deep too.
I wonder if there's a history of there being resistance or friction to introducing these notations, back hundreds of years ago when they were being introduced, or if, or how long it took, because it seems like, from my experience, you'll show people a APL or J or K expression, and just the reaction you get is just like, well, that's just, how could anyone read that? And it's just a language that you learn, and each of those primitives represent an algorithmic operation or some sort of kind of transformation. And when I hear you talking about, the calculus notation, and it's like it's this sort of agreed upon thing that it is, whether it's the best form of the notation, that's another question to be answered. But the notation itself is helpful. It subordinates detail. It makes things pop that are important. But it's lost on me. There's somewhere here there's like a beautiful argument for the spelling of these languages, but I definitely feel like I haven't found it yet.
Well, and with the calculus, the thing is that the notation was ahead of the actual understanding of it, because it was, hundreds of years later when they actually got into the analytics of it, that they found it actually how it did work and what infinitesimals were. But they were leaning on the notation to get them through the calculations before they understood what the calculations actually were. And it was I think it was in the 1800s, early 1900s, where this all came together, and they said, oh, that's how we can do this. Up until that time, they were just using it. They didn't really have the fundamental down to the very, very most basic fundamental levels of understanding. They were using it because it worked and because the notation worked more than they understood exactly what was going on. So in the case of talking about Arthur, I'll take a couple months to read it. That's where calculus ended up. It took a couple months, a couple of 100 years to really get it to the point where I know exactly what's going on. But in the meantime, I could actually use it. And if I've written it properly, if my notation is good, it's going to work for me.
Yeah, I mean, the problem that you have is the same problem why people don't go into math or whatever. I mean, some of them have a facility, but it takes effort, right? And let me ask you this question. Is French a better language for communicating than Portuguese or English or Chinese? I mean, whatever. I'm just saying, if you know it already, it's a means to an end. You're not even focused there. Most people aren't focused. They don't care about whether it's better or not, even if it is better. If that's what I know, it's what I know. You know what I'm saying? And so there's a big step function to get over. And by the way, that has to do with the marketing with Tintin data. I mean, because Tintin data in many ways reflects, the vector idea. You know what I'm saying? So it's a very powerful paradigm, but it requires a certain amount of effort to get into it. And then that makes it difficult because some people won't accept it because they're doing whatever they're doing. You know what I'm saying? So that's a psychological issue.
Yeah, maybe we can talk because we've I think spent most of the time talking about the 80s and your time at Morgan Stanley, and I'm not sure if you want to tell the story. You briefly mentioned that you were fired by someone that Arthur called a pinhead, or something happened there, and then I know you transitioned to UBS and then on to 1010 data later. Do you want to fill in some of the details there? I'm sure there's some more interesting stories and things that happened along the way up until what you were most recently working on.
Okay, so quickly, how I left Morgan Stanley. Basically, you always need a rabbi, and organizations are pyramidal in structure. So at the end, the higher up you go, the less room there is up there. And my rabbi lost, and some other rabbis won, and this guy's rabbi won, and so there wasn't a lot of room there. So in a certain sense, I'm exaggerating, that because we're politically on different, sides of the aisle. So then I left Morgan Stanley. By the way, Morgan Stanley treated me very well. And I was actually introduced by a partner, I can't remember his name right now, to a guy in UBS who was, very high up there, maybe second in command. He handled all of trading for the Union Bank of Switzerland. And what they were trying to do is they were trying to become like, Goldman Sachs or Morgan Stanley. And they were not as advanced as those places, and they wanted to really leapfrog and get there. And so he interviewed me to sort of build a platform for them so they could do their trading and catch up with, to the kind of stuff that Morgan Stanley, Goldman Sachs, and other major brokerage houses could do. And I said to him, why don't you buy some firm? It might be cheaper if you just bought, Bear Stearns, or I don't remember what other name I gave him. But he decided that he didn't want to do it. So we got the job of basically building the platform for fixed income, all of the technology. And so I ended up, running, which is something that I also did in Morgan Stanley, by the way, after I did the trading, basically running fixed income research and technology and building it from scratch. And for that situation, we hired Arthur so that we'd have his full attention on, making sure that the K platform really works. So again, all his products really are tested in the fire of reality. You know what I'm saying? And so that's what happened. And then eventually, I don't want to get into the details, but that whole thing fell apart. It's mostly politics. And at that point, we decided that we were done. I was done with working for somebody else, although that had been proved quite lucrative. Just give me a second because I have some notes here that might be. Yeah. So in 1999, Sandy Steyer, who's one of the originators of Tintin Data, myself, and a guy named Peter Miller, who's no longer associated with the company, he's an old friend of mine. um, end up in Palo Alto at Arthur's house. And what we're doing is coming up with the following idea, which is basically 1010 data. You now have a web. It's in its early stages, but why should everybody have to build the whole system in order to do analysis? I mean, just give us your data, we'll load it up, and all you have to worry about is doing the analysis and doing your queries and things like that. So that was the idea. So basically, we came up with that the cloud was a place to do it, that it was SaaS, meaning that you're not buying hardware on your own and installing all that stuff, and that you could do the analytics yourself. And the idea that we had there was something like Data. You have to understand Google didn't even exist. So, Yahoo was the thing, and people go to Yahoo or maybe, what's that, Vista? What do you call it?
Alta Vista.
Alta Vista, whatever. But we would do the same thing for actual analysis of data where numbers are involved and, things like that. And that's how the idea of 1010 data came. And that's where we started. And so the way that Arthur played into this thing is that we contracted to use his, the K platform. And that was the beginning of 1010 data. And eventually, that worked, and we sold the 1010 data about 5 years ago to the Newhouse people for $500 million, and it worked out pretty well.
You sold it for $500 million?
Yes.
And that worked out well. That's a very understated, sounds like it worked out very well.
By the way, I just thought of something. Another reason why why K or APL or all those guys didn't do so well is because the people that were developing the stuff wanted to make money. They didn't want to give it away. For example, Dialog APL. It's a great product. But people are selling it. They didn't go the open source route. I mean, Arthur could have gone the open source route, but Arthur's doing very well. He's in Turcos and Caicos Island right now. You know where he is, right? He's hanging out. He's in the Bahamas someplace, and working on Shakti, whatever. I'm just saying, but he's got a lot of money. I mean, so it worked out well for him. This has worked out well for me. But if if people had really at the right timing, in the right place, made this stuff free or whatever it is, maybe it would have taken off more. You know what I'm saying? I mean, but then on the other hand, but so what? I mean, yes, I have this great desire, and I do. I mean, there's a certain way in which I feel like almost like a prophet for K and APL and all that stuff, but we didn't go that route, and that did slow things down. You do have to understand that.
Yeah. Do you have thought? Because I know this is. I think it's inspiring for the APL story that I've heard that Arthur sold K4 and Q for $100 million, which arguably makes it the most expensive program in the world because it was 50 kilobytes of code. So I heard from someone once that it was like per kilobyte of code, it was the most expensive piece of software ever sold, which is, obviously they were selling KX, the whole company, which came with customers and stuff. So it wasn't just the K program and Q. But that's two businesses though, KX and K, and what became Q that got sold obviously very successfully, and now 1010 data. I guess so. There's two questions: is do you think the world would be different today if everything was open source? Because technically J is open source. There is an open source APL that does exist, so it's not like that. There's zero open source array languages, and that's the thing is I've these stories of people building successful companies on top of array languages. They're not like, this is the first time I'm hearing of the 1010 data one, and it took me a couple months to find out about the KX one, and even when you go search for that, the articles that come up are basically like the news briefings from some, it's not like this was on the front page of the Wall Street Journal or even on page 26 in section 4. Like, these stories aren't really widely reported on. And I wonder if that's intentional or because it seems like there's definitely a ton of people out there that have built very successful careers on top of these languages, but it's not as widely known, at least from someone who's only gotten into this world in the last couple of years.
Yeah, I got to tell you, it's always been a source of mystification for me. I don't know. See, especially when we're doing 1010 data, because we're trying to sell it, right?
Mm-hmm.
I mean, we're trying to get a lot more people involved or into it, or scale it or whatever. And it's always been very hard. I think a lot of it has to do with psychology. I'm not, it requires a certain kind of person. I mean, I don't know. For example, I mean, Whitney can be very dynamic when he talks if he wants to, if you can get him to talk. But I mean, like, for example, I had dinner with Steve Jobs, right? Jobs. And I don't want to get into all the details how that ended up, but this guy is, blessed memory. He has a charisma. You understand? He has a charisma. The way he behaves, the way he acts, even the way he dressed. He was so well dressed. I mean, with the turtleneck thing, I don't know. Maybe it's just luck. It requires something. For example, that I don't have. I don't know. I mean, it's why something works and why something takes off and why something doesn't. Maybe 100 years from now, somebody will rediscover race, and they think that they invented them, which is fine, and maybe they'll be happier, luckier, and we'll be able to promulgate it more. I don't know.
Yeah, you were talking about the fact that, open source might have gotten in the way. And I think sometimes you could look at it and go, yeah, maybe that did hold it back. But I think actually Jay does prove the point that I don't think it's open source that holds it back, because Jay is open source. But, and this is the big but, when you want to use it, you have to get thinking at a different level. You have to dig in deeper. You have to stop and actually... It takes effort to program in J. Even now, when I'm programming in J, it takes effort for me to do it. It's not something that I go, oh, I'll just dash this off. I'm not that kind of a programmer. I'm not that smart. But in the process of using the language, it allows me to go through and refine my thoughts to the point that they do become clear. And what I end up with in the end, I'm usually very happy with, because it does that. But if you were to say to somebody, you know what, I can make you, I can extend your life, say 20 years. You can live 20, 30 years longer. Would you like to do that? Oh yeah, okay. Okay, so now what you need to do is you need to restrict your diet, you need to exercise every day, you need to do all these things. And if you do that, you've got a very good chance. And if you live a, risk, have good risk assessment, chances are you're going to live 30 years longer. And most people know that, because that's common knowledge. If you are healthy and you exercise, you'll live longer. Most people, or many people, won't do that, because that's a lot of work.
Yeah.
And why would you do it that way? And I think that becomes the challenge with some of these languages is it is work to think this way, even when you know them. You have to do the work. You have to be the kind of person that goes, you know what? I'm going to work at this, and that's okay. It's not easy. That's okay. I'm just going to work at it. And I think that's not a common, as you say, psychological trait within people. I think the people who are willing to go, oh, this is really intimidating, or this is really difficult, but I'm going to stick to it, they're not that common. And usually, and quite often, as you say, when you talk about the sales of these languages, people who can do this, they are quite successful.
They're also, I think, it requires a certain amount of intelligence, a lot of intelligence. You see, you don't have that many people. See, us guys, we like languages in general, right? I mean, I wanted to get maybe, it's not enough time, but I mean, like Jay. I mean, Jay, it reminded me. By the way, I knew Iverson very well. I had a really personal relationship with Kenneth, because I sold a lot of products. I was one of the first IBM. Well, I was on the first class of IBM salesmen that sold software only. And what IBM was doing is trying to sell, the APL family, because it drags a lot of iron with it. So I interacted with Iverson all the time, So we're good friends. And I also know all his kids and his wife. when he was at IBM, he was a little bit constrained, and he couldn't do all the things he wanted to do with the language. And the APL was a smaller, simpler language, even though it's pretty big. When he went to J, he just went wild, And you see all the things that they put in there, and it's hard. I mean, for some people, it's difficult. There's a lot to know. And see, Arthur Whitney's attitude, number one, he didn't have that luxury. And the reason why they like him in finances and why people are willing to learn that is because the stuff was unbelievably fast and unbelievably good at rendering those kinds of algorithms. So he got a good foothold in there. Those people are all very smart. Trust me, the guys on Wall Street are not stupid. And he gets that, And so he emphasizes more simplicity and speed. I don't know. I mean, I really don't know what the benchmarks are. I don't know what the fastest APL today is and how it would compare with K or Q, or the same thing goes for Q. What I'm saying here goes, equally for Q. And I don't know about J. I mean, a lot of people add things that are interesting from a language point of view, but not necessarily from a performance point of view, And I don't know. I mean, by the way, I don't want to criticize because I don't know J. And and it could very well be it's really fast and really great and really scales and everything like that. You have on the one hand expressiveness and another thing, speed.
Yeah, I think that's kind of what I think is the golden path for array languages is basically trying to follow what Arthur did, and that the fact that it's a somewhat esoteric language, there's a certain amount of a barrier to entry in terms of the way you have to think about it and the way you spell it. But if you can come up with a blazingly fast array language where potentially it's even limited, you take away some of the functionality that exists in APL and J with nested vectors and stuff, because that won't map as well to accelerated hardware. But if you can find some kind of language that is just an order of magnitude or 2 orders of magnitude faster than everything out there, and it runs on accelerated hardware, that's going to be something that there's going to be a set of people that can't ignore that, because that's exactly what they need. They don't care what it looks like. If it's faster, they'll want to use it. Which is why I'm convinced there's some secret company out there that we'd have to keep interviewing people, and then one day we're going to find out, oh yeah, I'm sipping my Mai Tai on Hawaii. I sold the company for however much money, and just no one's ever heard of it, because it sounds like there are more and more of these companies, as we just discovered.
So this is interesting, because we're distinguishing two things we like about the languages. One is the speed. As you say, people have paid big money to use K simply because of the speed. And as you say, Connor, don't care what it looks like. In fact, I remember Jeanette Lustgarten once saying to me, all our customers, all our KX customers are people for whom everything else has failed. It's like nobody wants this weird maverick technology in their stack. The only reason they've got it is because nothing else will do the job. That's pretty harsh, pretty self-deprecating. And then there's people who actually like it. So when I sit down to write a piece of Q code, I think the last job I did, I was hacking sound file metadata to import a bunch of stuff into Apple Music. I published a blog post on that last week. I was thinking about what Bob was saying a few minutes ago about, this stuff is hard. You've got to work at it. I'm thinking, as I start that, I've got a sense of anticipation. I'm a little excited about what I'm going to do. I don't quite know what the end result's going to be. I'm pretty confident I'm going to get this stuff into my Apple Music library. But what's the script going to look like? Well, what I'm hoping is it's going to look kind of cool. By the time, I don't know what the code's, I haven't solved the problems. I don't really know what problems I've got to solve until I've been all the way through the data. But I'm hoping that by the time I finish, I'm going to have something I want to show people. I'm going to say, hey, that's pretty cool. Could you believe I got the job done with just that little code? Can you believe that the code is this readable? It's this clear what's going on, something like that. It's exemplary. So there's an aesthetic thing, and it's completely separate from the speed. In that job, I didn't need it to be fast at all. It's pure delight.
Well, but there's two issues here. A person might go in for the speed, but there's speed in two ways. Speed, number one, is that it executes quickly, right? But speed number two is how quickly can you implement something? And that's where the language, the power of the language, and it should not be underemphasized. That's really, really important, right? Because you can do very complicated things and maintain, I'm talking about problem level complexity, it's irreducible, right? You can ride that very well if you have a language that doesn't force you into all this minutia and stuff that you can't, deal with. So there's a speed to development and there's a speed to execute.
Yeah, it's interesting that you say that, because I just literally got this question in my defense last week, because I used the word power in my thesis I don't know how many times, referring to these languages. And one of the comments I got was like, what do you mean by power? And when I gave an answer during the defense, which was okay, but I thought about it afterwards, and I realized that like power is an overloaded term, and you just described there's different types of power. And I think the version I was using was more in the speed in which you can write something, and also like how much you can say. Like it sort of ties into expressiveness. Is the power of the glyphs is that they're rank polymorphic, and that you can do so much on so many different structures with like so few keystrokes. But at the same time, there's also another power in that. Like if you're using a K or an accelerated APL, it's also extremely fast. And I think there's a article online with an interview with Arthur, and one of the questions is about like, oh, it's an interpreted language, isn't that slow? And then it's like, well, no, like it's a myth that like just because it's interpreted, it needs to be a slow language. So it's interesting that you commented exactly on something I was thinking about last week. Is like, what does power mean? And it actually means multiple things, and all of them really apply to array languages.
Yep.
All right, so we are well past the hour mark, but I feel like I want to keep going, and you said we don't have enough time. I mean, I'm not sure. I sort of kind of want to ask. I mean, this is definitely the most famous people have come up in this episode by far. We had D.E. Shaw first, then Jeff Bezos, then Bill Gates, then Steve Jobs. Are there any other, just in case, if you've got a Pokemon collection of well-known people that we should?
Okay. Oh, here's a good one. Alan J. Perlis. He's the first Turing Award winner. He used APL to teach computer science at Yale, excuse me. That guy was a great guy. I mean, he invented one of the inventors of Algol, and he became a real great APL guy.
Did you end up having like conversations, or do you just know about this impact? Because I know.
No, I spoke to him. Yeah.
Wow. What was that like?
Oh, he's great. I mean, he what he did? He said, look, it's really cool. I can teach a guy APL in a week, and then, well, instead of just talking about how you would implement an assembler language, right? I now have an implementation language. Remember, that's where you get the power to implement something quickly, right? And so he used APL. He taught them APL, and then he taught them all the concepts of the different computing, and he implemented these things, what a macro language looks like, et cetera, et cetera. And that's what he was talking about. He thought it was a great educational thing. And while he was there, obviously APL was a big deal. But again, I don't know why these things don't sometimes stick. Other people that are interesting, okay, Benoit Mandelbrot, of blessed memory.
What's the connection
with Benoit Mandelbrot? Okay, so we had this is in Morgan Stanley, where we're doing trading, and he was he consulted with us. We were looking at attractors and things like that, and fractal things. And he was helping us out. He thought that was a good idea. We had, and also he did. I went out to there's this thing called Society of Quantitative Analysts, which is an organization of people that are quantitative, very old organization in finance, and I was on the on the board there, and so we used to go and set up things. So I set up a trip for all the finance people to go and take a look at what was going on at IBM. and they might have an impact on this. And and Mandelbrot, Mandelbrot was there and he gave a talk. There's another guy named Shlomo Winograd who invented the FFT, the fast Fourier transform at Yorktown Heights. There was John Koch, who was the guy who invented the RISC architecture, at IBM, and he loved APL. I remember him saying how he thought that's the way the architecture should be utilized. In other words, big arrays and vectors and things like that is the way that you could best. It's a thing that would map most nicely into the RISC architecture. Then there was Leon Cooper, who was a Nobel laureate, who helped us with some neural net type stuff that we were using in trading at our place. What's interesting is not the technique. What's interesting is when you get a real smart guy like Leon Cooper, who's was a scientist, right? And when they apply their brain to trying to understand something, he was amazing. I mean, we gave him a problem where we gave him some spreads. We didn't tell him what it was because we didn't want to, and we wanted to find out when spreads and stocks, diverge because maybe somebody's got internal information or whatever, and we get killed on those because we were just betting on the spreads. When they get big, they'll shrink, and when they're small, they get big. So we gave him the data. It's amazing what he was able to figure out because he's a good scientist. Just looking at the data, he figured it out. Another guy, great guy, Philip Wolff. He was the guy who invented quadratic programming. And quadratic programming is, this whole idea of, I'm trying to remember the guy's name now. God, it was Yorktown Heights. This whole idea of portfolio analysis, risk versus return, risk return.
Sharpe ratio?
Sharpe, yeah, but I'm trying to remember the guy who brought it. There was another guy. God, he's the guy who invented this idea on Wall Street. But at any rate, the whole point is that it's all based on being able to do a quadratic program. It's the extension of linear programming, and that was Philip Wolff. And Philip Wolff loved APL too, and he showed us we're having trouble. This is an interesting problem. We wrote the algorithm and for quadratic programming, and it was unstable. Depending on what numbers you gave it, it would just take it wouldn't converge. And I remember he came by, he looked at our code, and he said to them, "What are you using for zero?" So we said, "Well, we're using zero." He says, "Well, that's naive." He says, "Zero is too small." And the point is, what value do you use for it? And actually, this is more like an art. I mean, it's really, obviously, it has to do with chaos and everything like that. But so he gave us a number. As soon as we plugged in that number, it started to work. Philip was great. I don't know if these guys are still alive. So anyway, those are other guys. And Irvin Ludowski-Berger, this is another guy. He was an IBM vice president, corporate vice president, not a VP. I mean, I'm talking about a real VP, And we were having trouble with APL. It wasn't going fast enough. This is when we're still doing APL on the mainframe. And he actually had something done in the architecture, changed the hardware so that we could get more bang for the buck. And the IBM, the thing that came after 370, I don't remember what it was. He's a very interesting guy too. And of course, Ken Iverson, I mean, we all know Ken, so.
It's surprising how many, I don't want to say famous people, but just like well-known people in computer science secretly, or maybe not even secretly, but just had a fondness for APL. Like you just added a bunch of names to my list, but I also know like Alan Kay, Small Talk, he was a big APL fan. Alexander Stepanov, who is very important in the C++ community, he was a big APL fan. And just all these, I can't remember if I just mentioned Bill Gates, but it's odd that there seems to be this like trend of a lot of folks that had this fondness for APL, but it was just either like a side thing or it never became their main tool that they were working with. And I wonder, yeah, it's just curious. Like the more and more we do these interviews and the more people we talk to, I used to think of APL as this kind of, esoteric. I've read the 10 programming languages that are dead, and it's on that list. But then sure enough, there's it's not just like a small collection of people that are interested in we just discovered today that Bill Gates not only was an APL. I'd heard that he had a little manual in his desk drawer, but I hadn't heard that he implemented that's more than
he did an implementation of APL.
That's more than just being like, oh, I find this interesting, like to take the time and actually and there's other folks that have done the same thing. Rob Pike, who worked on the Go language, and his two other co-creators, Rob and Ken Thompson, they all did little APL interpreters all at one point. And it's very, very curious that this seems to be a trend amongst on some level of infamy or fame, these computer scientists. I mean, who hasn't heard of Bill Gates?
Right.
Not so much a closed off little niche, more like the way we think these days of a fungal network in the forest.
Yeah.
Yeah, right, exactly.
All right. Well, Bob, Stephen, do you have any final questions? Bob?
You've had this wealth of experience. You've met all these people, Joel. If you were to talk to somebody starting out, either just working with array languages or just generally if they're programmers and interested in this kind of stuff, would you have any advice to them about what, in your experience, what's the best way to start out with this stuff and have a fulfilling experience with it?
Well, it depends on when you get a person. I mean, unfortunately, there's an ocean of chaos, and most of it is nonsense. There's like millions and millions of people that are programming, people that are using their cell phones in some way. They're kind of doing something like programming. And so a lot of them, their minds are already invested in something else. So it's hard. It's hard to find somebody that, has, beginner's mind. So it's tough. We hired two guys into 1010 Data who came to array languages on their own. We put an ad in Reddit. There's a Reddit thing on array things or whatever. And these were people that came to it on their own. They said, gee, this is a good idea. This is an interesting thing, So it's hard to say, I guess if a person loves languages, right? For example, we didn't talk about Lisp. I think Lisp is pretty orthogonal to all these things. And I have a certain respect for it. And there's certain things that are easier to do in that, And it's really different. I mean, Fortran and COBOL and Scala and, and I don't know, all these languages, they're all more or less the same, But there are some different ideas. And people that like languages would be interested at least in looking at it. I mean, now you can get stuff. You can get a version of K, you can get a K, APL, things like that are, free, right? So, point them out, point it to them. I don't know. It's hard to, I wish, you say all this experience that I've had, it mystifies me. I still can't figure out what makes a person like something or not like something, Sorry, I can't do better.
Well, I think what we need to do is we need to get a T-shirt that says 1 potato, 2 potato, 4 loops, and then not me.
Yeah, well, that's great. Well, yeah, but now you're in the area of marketing, and sure. Hey, look, I mean, if you get a clever enough person that gets something going, people will go, they'll go nuts, It's just that when you go nuts and you hit a language, it's hard. As you said, it takes effort, right? And, it's the slow thinking, fast thinking kind of thing. Most people just want kind of stuff to happen easily. The idea of putting some effort is like a lost art.
Yeah. I think potentially part of the marketing issue too is that for the folks that are in the category of, they fall in love with this paradigm of which I consider myself a member, that rabbit hole that you fall into is very, very, it's a deep and it's not a gradual thing. It happens so quickly that there was a couple months where I didn't understand trains and point free. But then once you get the snowball rolling, it starts to roll so quickly, and the hole is so deep that very quickly the videos that probably I was posting on YouTube before that were approachable, there was like 2 or 3 of those videos, and now I'm just like, well, check out this like combinator point free blah 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 stuff. It's awesome. I'm not really going to get into explaining it because I'm just having so much fun with this. Like we went from 1 order of magnitude, ability to think in my head to 2 orders of magnitude, and you've now become that professor that isn't really that great at teaching the material because they're too far removed from what was it like to be confused. Which is why I think there's some videos that Rodrigo, who's a employee at Dialogue Limited, and he's really focusing on sort of introductory and why you might. I think even Richard Park, he had a recent video at Appleseeds about like worth learning, or sorry, I can't remember the title, something about worth learning and even better to like master it. And he showed just some simple things of like outer products. Like I remember the first time seeing an outer product. Like I had never seen that in another programming language, and I knew a bunch of programming languages. And yeah, so I think, yeah, I am also mystified, but like there's got to be a reason, and we'll as a group we'll figure it out. And t-shirts I think are the starting point. We need some potato gifts, and yeah, there's something there.
See, one of the things about APL, because it's a mathematical thing and all these things generalize, is what you don't know doesn't hurt you. If you didn't know that there were vectors and you said 1 + 1 or A gets 1, or in K you have do and while and all that kind of stuff, you could be programming and never know that you were doing an array language. And then later on, when you learn an idea, you don't have to know everything in order to do something.
Right.
That's one of the advantages of a clean, well thought out something that is exploiting this whole tradition of mathematics. That's an advantage.
Yeah. Even to this day, yeah, there's a percentage of each of K, J, BQN, and APL that I don't know. There are operators that I've never touched, and in BQN especially because it's the newest, there is I think a whole 4 or 5 operators that have been introduced in that language that I have no idea what they do, but like that doesn't affect your ability. It probably means that you're spelling 3 or 4 more characters in some cases to solve some problem. But like that just means that down the road I'm going to stumble on this thing and be like, oh my goodness, I've been doing this with 3 or 4 characters, and that exact thing that I needed existed there. And it's that's what I was talking about with the deep rabbit hole. Is you get started, and as you go deeper and deeper, you just realize, wow, this is even more and more powerful.
For example, inner product, right? You can just the plus dot times. Just take plus dot times. Think of all the things that you can do with plus dot times for which you have operators. For example, you want to sort something. If you have a permutation, right? You can do it with an inner product. Because, by putting zeros and ones in a matrix, you can make that matrix do a sort. You can make that matrix give you any permutation you want, right? By putting ones and zeros. So it's interesting how all these ideas, connect to each other. I mean, I think Apter was talking about that. How many things make sense, in the language? I mean, it's just fascinating.
Yeah, I think it was Adam as well, was when Stephen was talking about that, or Stephen Apter was talking about that, was saying that at some conferences his dad was at, people would be walking around trying to figure out ways to use inner product with different primitives and come up with what they could do. Yeah. Exactly.
When he said that, I said to myself, yeah, but I'm saying, just think about it. You can do indexing effectively. Indexing is an inner product. I don't know. There may be some deep thing in there. I don't know. Also, the way that a lot of proofs are done in APL, you start with nothing. The concept of an empty something is a fundamental idea. So you can derive, the plus reduce of iota 0, right? You can do that by some proof that involves starting with, I don't want to get into it. It's too late. Anyways, but look, if we want to talk again. By the way, people that you should talk to is Adam Jacobs. Seriously, you should talk to Adam Jacobs. And you should talk to maybe John Ernest. Okay? Yeah, he's chicken farming out in, I don't know, Washington State, but he is he's a young man. He's somebody who came to this on his own.
Interesting. Stephen, you have a last comment or a question?
T-shirt story.
Okay.
1976. I was on the top deck of a number 13 bus in London, and I was wearing an IP Sharp Associates t-shirt. As I stood up to go down, the back of my t-shirt becomes visible. No one can see it when I sit down. On the back of the t-shirt is the ripple shuffle expression. It exactly describes how you take a deck of cards, cut it into, and so they all interleave. And as I descended the stairs of the bus, this voice behind me in an American accent says, "Look, Martha, an APL expert."
Awesome. I think there's no better way to end it than that. So yeah, Joel, thank you so much for coming on. I've been looking forward to this conversation for 2 weeks basically since Stephen recommended you, and I know our listeners are gonna absolutely love this conversation. So hopefully at some point we'll be able to have you back and tell any of the stories that we weren't able to get to today. But yeah, thank you so much for taking your time to come on and chat with us.
It's been a pleasure.
Awesome. And with that, we'll say happy array programming.
Happy array programming.